If you want an AI to do any meaningful work for you, you have to feed it context. Without a clear set of rules and data to follow, the model just generates generic, unusable slop. We usually assume that providing this memory requires building a complex synthetic brain from scratch, an artificial layer that sits between us and our tools. This leads to the first bet a lot of tech workers make: vector databases. You take every note you've ever written, turn them into numbers, and ask the model to mathematically search for similarities. People sit down on a Tuesday, spending 3 days indexing years of notes and fighting database servers just to get the system running. But the result is often brittle. Search for a specific project detail, and the AI returns 9 vaguely related, completely useless notes. This friction happens because we try to build different memory systems for different tasks: one for creative work, one for software, and one for business strategy. But in an AI workflow, all 3 of these disciplines rely on the exact same thing: accessible, organized context. Once you solve the context problem, the walls between these roles disappear. Creative, technical, and business work become the same fundamental task, just wearing different clothes. Why are we building fragile, expensive databases to solve this, when the most efficient AI memory system has been sitting natively on your desktop since 1995? Then there's the second bet, the LLM Wiki. This is a system where an AI actively maintains and audits a massive web of linked markdown files. It's an elegant concept, and it's essentially a modern version of Vannevar Bush's 1945 Memex, a theoretical machine designed to store and link human knowledge. The trade-off is maintenance. The wiki only stays useful if a secondary AI constantly runs in the background to flag contradictions and fix broken links. Both of these bets fail because they ignore the cheapest, fastest, and most human-readable alternative already at our fingertips: the standard local folder system. The folder system works through a mechanism called position-addressed memory. In this hierarchy, the physical file path provides all the context the AI needs. When an AI opens a file, information cascades down, automatically inheriting every rule. The AI absorbs the brand voice, production roles, and shot list from parent directories. To see this in a high-stakes environment, look at the AI company NLP Logics. They needed a massive volume of work: 4 distinct video animation series, multiple voiceover scripts, and a custom animation pipeline. A traditional agency would typically staff this with multiple teams and require at least 3 weeks for a first delivery. Because the folder system handled the logistical heavy lifting, automating the file routing and brand matching, I delivered all 4 fully animated and voiced videos in a single day. The speed didn't come from a complex retrieval system. The literal namespace and location of the folders did the work. There's a common fear that using AI in this way will eventually replace human creative taste. In practice, the system does the opposite. It handles the logistics, resizing exports, matching color codes, and naming files, which leaves the human with more time to focus on the actual creative decisions. When logistics are offloaded to the folder structure, the traditional agency business model changes. Creative work, software architecture, and business strategy are no longer handled by separate departments. They become 3 different lenses viewing the exact same artifact. This creates 2 distinct products for every project: the creative deliverable for the client and a reusable folder structure that functions as valuable internal IP. By removing the need to staff every logistical hurdle, a single person using this architecture can match the output of a 150-person enterprise. True systems thinking means building your core structure once and letting all future business, creative, and technical problems solve themselves on top of it.